In this video, we're going to introduce the idea of hypothesis testing. Beginning with, just a little review and some AP questions. So, the box plots above compare the television ratings for two competing networks. Which conclusions can you draw from the box plots? That Network A has more shows than Network B. That is a no. We don't have any idea about the actual size of the samples from the box plot. It doesn't give us any information about that. Network A has a greater range. Well, that is true. You'll notice range, it is larger for A than for B. Range, of course, is the difference between the high and the low. So that's true. And then Network A is higher rated than B. Well, it does appear like medians are higher, Q1, Q3, and maximum. So yes, I would say that Network A is higher. So the answer is 2 and 3. A poll was conducted in the San Francisco Bay Area after the San Francisco Giants lost the World Series to the Anaheim Angels about whether the team should get rid of a pitcher who lost 2 games during the series. 525 adults were interviewed by telephone, and 55% of those responding indicated the Giants should get rid of the pitcher. It was reported that the survey had a margin of error of 3.5%. Which of the following best describes what is meant by the margin of error? About 3.5% of respondents were not Giants fans. Well, that's wrong. We know what margin of error means. It helps us build our confidence interval, 55 plus or minus 3.5%. This is where we think the likely proportion lies. It has nothing to do with who is a fan of what. B, it's likely that the true percentage that favor getting rid of the pitcher is between 51.5 and 58. I think that's going to be it, but let's keep going. 35% of those contacted refused. No, it has nothing to do with non-response rates. 3.5% of those contacted said they had no opinion. No, it has nothing to do with people that, again, didn't respond. 3.5% thought their answer was an error, and they're likely to change. No, it is B. Margin of error helps us build a confidence interval. All right, so we're going to start talking about hypothesis testing, and we're going to do that by talking about a mathematician, and some of this may be legend, but the story of a mathematician named Henri Poincaré, who was considered the father of modern statistics. So Henri Poincaré was a mathematician who believed that he was being cheated by a local bakery. And I'm going to simplify all these numbers and, of course, kind of Americanize this. So we're going to say that the bread he was buying was listed as weighing a pound. And Henri was convinced that the baker was not actually giving him bread that weighed a pound. So he began with what's called a null hypothesis. We usually write that with like this. And the idea, he said, was, I know that they tell me that the bread weighs 1 pound. And I'm going to begin assuming that that is true. But I suspect that it is not 1 pound. I suspect it's less. So the alternative hypothesis, he said, was that actually, I believe it is less than 1 pound. He didn't guess what it was, only that it was less than what he was being told. Typically, when you see this, and when we do this, you should also define your parameter. You should say mu, the number I use, is the mean bread weight. Okay. So this is how he began. Then he took a sample of bread. Now I have simulated a sample here, and I'll explain. I will pull this in. So what you see here is I created a normal curve centered around a 1 pound loaf, and I drew a week's worth of bread. Assuming you bought a loaf every day, I graphed it, found the average. I'm sorry, it's a little small. It was 0.985. So the idea being, or what I just did is I simulated, let's say the null hypothesis is right. The bread really weighs a pound. But we understand that in baking and in manufacturing goods, there might be a variability that's inherent here. So we have to understand that. So again, I centered it. I assumed the null was right. The bread weighs a pound. That's what it should. No one is cheating us, but there might be a little variability. Then I simulated using Tinkerplots. What if I did 100 weeks like this? Okay. Now the point of this is that Poincare did begin doing this, and he did take a measurement, and his measurement was 0.9. After a week, he measured his bread every day, he calculated the mean, and it was 9/10. Now you see from my graph that when I collected 100 weeks, my average came out 1.0002, so very close to a pound, and that's what you'd expect. I also shaded 0.9. So of the 100 weeks, 3 out of the 100 were 9/10 or less. This is what's referred to as a p-value. And the idea is that within this inherent variability, there is a chance that even if the null is true, that this 0.9 occurs. What is that chance? In this example, it apparently is 3 out of 100. There are 3 samples that got 0.9 or less, even though I'd centered everything around 1. So, at the end of this situation, Poincare said, well, that's evidence. I think I'm being cheated, but 3 out of 100, that's not great evidence. So Poincare began doing this for a year. So what you see here is a simulation I created. Again, same curve. I simulated 365 days and calculated the mean, 1.00956. And then I did 100 simulations of that. So like 100 different people's years of bread. And I got 0.999 as the average. The lowest value, and I'm sorry it's hard to see, is 0.98. The largest is 1.02. So now if you said to Poincare, well, what's the probability that 0.9 or less would occur? The probability is 0. That should never have occurred. According to this distribution, 0.9 is not even possible. So this is what Poincare took as evidence, and he went to law enforcement and informed them that he was being cheated. And I think my favorite part of this kind of legend about Poincare is that when law enforcement interceded, when he was given his money back, and retributions were made, he began to go into the bakery and found that all the loaves he was being given were oversized. So he thought, well, now they're just trying to get me to be quiet by overcompensating. So he began to send other people in to pick up bread. And when the bread came back from these other people underweight, he took them back to court and said that, yes, now I'm being, given the right amount or more, but they're still cheating everybody else. So he is considered, as I said, this kind of father of modern statistics and hypothesis testing, because how do you create evidence? What's significant? How big does the sample size need to be? What did I believe was true? What am I trying to prove is true? These are the cornerstones of hypothesis testing. In the next video, we'll talk more about nulls, alternatives, p-values, and how we phrase a conclusion.